Hi everyone, and welcome to another video of the SAFI webinar series. In this video, we are going to have an overview of the impose displacement command. Impose displacement can be defined using the joint attributes command. Joints with an imposed displacement should not have any support in the direction of the imposed displacement. The imposed displacement corresponds to a support for which movement in one direction is forced. It is important to keep in mind that an imposed displacement is considered in all the load combinations. Without further ado, let's start our demo. To add an imposed displacement, we need to edit the joint attributes. In the Joint Attributes dialog box, we find the Displacement tab. We can activate an imposed displacement by checking this box. So, we can apply displacements. We can apply imposed displacement in translation x, y, and z, and we can also apply imposed rotation in the directions x, y, and z. It is possible to assign a local coordinate system to apply inclined positive displacement. So for example, if we want to apply an imposed displacement in the x direction, we can activate the displacement along x and we specify the displacement. In this case, 30 millimeters. It is important to make sure that we don't have a support that is activated in the same direction or a spring. We then click OK to validate. When we impose a displacement, you will see this sign on the screen. The arrow points to the direction of the imposed displacements. In this case, it's x positive. It is also possible to edit or add imposed displacements to a series of joints using the selection command. We select the joints that we want to add this condition. Then we use the command edit joint attribute. Then we go to the displacement tab and we activate that condition. In this case, the displacements are along the axis x. We make sure that we don't have any support in this case. We then click OK to validate. So in this case, we see these two joints share the same imposed displacement condition. Now let's visit another example. This is a 2D model where we applied an imposed displacement at this joint. The value is minus 25.4 millimeters or minus 1 inch. So if we run the analysis, we can see the effects of the imposed displacement. If we look to the load combinations, we have two load combinations. The first load combination, where we applied a very small load, we did that to showcase the effects of the imposed displacement's condition, and the second load combination is where we applied the load on the 2 stories of this building. Now, if we focus on the first load combination, and we display the displacements, we can see that the structure deformed under this imposed displacement condition that we added to this joint. So, that's one way how to see the effects of an imposed displacement. So, we create a load combination, and in that combination, we will use a very small load factor for all the basic loads. The imposed displacement effects on the structure will be easy to see in the results. We can also display the results for the second load combination that includes the total load on the stack. That's it for the imposed displacement command. Thank you for watching and catch you in another one of our webinar series videos.